Hello and welcome to Chapter 6, Learning. You may notice two things. One, I asked you to watch a video first before watching this lecture that has to do with classical and operant conditioning. The reason I did that is because it does a really good job of explaining these two things, and I thought I'd just let them do it. Then, so basically take a moment and watch that video if you haven't already. It's pretty short, it's interesting, I think it'll be worth your time. So, since you're still with me, the other thing you may notice is that this is Chapter 6 and not Chapter 2. The reason I'm doing it in this order is that learning, I think, is more applicable and appealing in that way to learn about first, because just learning about the brain is a lot of biology and nitpicky details that it is interesting and you do need to know it, but I think if you learn about learning and memory first and then go back and learn about the brain, it's a better order. So just for a chapter overview, we'll talk about how do we learn? What are the processes involved in it? I will talk a little bit about classical conditioning and operant conditioning, but again, make sure you watch that video. I'll also talk about the biology and cognition involved in learning. Also talk about learning by observation. So, how do we learn? Learning is acquiring new and relatively enduring information or behaviors through experience. So this could be something that you do yourself or that you watch someone else do. And I say relatively enduring because the information doesn't always stick. Our brain keeps only what it thinks is going to be relevant or anything we force into becoming relevant through practice. There's something called associative learning. This is learning that certain events occur together. So events may be two stimuli or a response and its consequences. We'll talk more about this as well. There's also something called cognitive learning, and this is when you learn new information by observing events, watching others, or through language. So as I mentioned, there are two forms of conditioning. Classical conditioning, where you learn to link two or more stimuli and then anticipate the events. This is the dog and the food and the bell. So the food and the bell were the stimuli, and then you anticipate that food is coming, which produces a respondent behavior. In operant conditioning, you learn to associate an action and its consequences. If I do this, that will happen. So here you're an operator. So like the dog wasn't doing anything other than standing there in the classical conditioning things, but when you are doing something, you are learning what's going on. You're the operator. That's why it's called an operant behavior. Trying to make those. So like I said, if you haven't watched this video, it's worth your time. Go ahead and do it to tell the difference between classical and operant conditioning. So time to quiz yourself. An experimenter sounds a tone just before delivering an air puff that causes your eye to blink. After several repetitions, you blink to the tone alone. So what is the neutral stimulus? The unconditioned stimulus, unconditioned response, the conditioned stimulus, and the conditioned response. The answer is the neutral stimulus was the tone before things happened. You normally don't blink when you hear tones. The unconditioned stimulus is the air puff. It doesn't take any conditioning at all for something to puff into your eye and make you blink. The unconditioned response, just like I said, is a natural thing that you would do in response to something happening to you. That's the blink to the air puff. The conditioned stimulus is the tone after things have been conditioned. So at some point, you don't even need the air puff. You just hear the tone and you blink, which is your conditioned response. Another way to quiz yourself, why are habits, such as having something sweet with that cup of coffee, so hard to break? Since we're in a chapter on learning, I'm sure you're probably thinking, I've learned to pair, and that's true. So habits form when we repeat behaviors in a given context and as a result learn associations, often without our awareness. So, for example, we may have eaten a sweet pastry with a cup of coffee, often enough to associate the flavor of coffee with the treat. So that cup of coffee alone just doesn't seem right without having a sweet treat. This is Ivan Pavlov. He was the one who introduced the idea that the whole ding foof slobber to dogs, basically, the classical conditioning. He explored conditioning processes such as acquisition, extinction, spontaneous recovery, generalization, and discrimination. So a lot of important things that have to do with learning. We'll talk about each one of these. So acquisition. This is the initial stage where you link a neutral stimulus to an unconditioned stimulus. Here, a neutral stimulus begins triggering the conditioned response just by itself. And a funny example of this is a psychologist, Michael Terrell, I guess his name is, said that his first girlfriend loved onions, so he became to associate onion breath with kissing. Before long, onion breath sent tingles up and down his spine. So, first, the unconditioned stimulus is a passionate kiss. Of course, his unconditioned response, being a healthy male, is that he liked it. Sexual arousal. However, he learned that every time he kissed this particular person, this neutral stimulus of onion breath produces sexual arousal. So whenever he smelled onion breath alone, it got him excited. Which is sort of funny because not just his girlfriend has onion breath, and so that could be a little awkward. But anyway, it has to do with classical conditioning, and it's a funny example, so I thought I'd share. So, in talking about extinction, this is the weakening of a conditioned response when an unconditioned stimulus does not follow the conditioned stimulus. Spontaneous recovery is the reappearance after a pause of a once extinguished conditioned response. So you're sort of relearning it or reassociating it or strengthening the association. So let's go through this example of acquisition, extinction, and spontaneous recovery. The rising curve here on the bottom, you see time is lapsing on the x-axis going from left to right, and strength of conditioned response from weak to strong is on the y-axis, or the one going up and down. Here, the rising curve, which is simplified here, shows that the conditioned response rapidly grows stronger as the neutral stimulus becomes a conditioned stimulus due to repeated pairing with the unconditioned stimulus. So the more you have the bell associated with food, the more likely you are and the quicker you have that response of salivating just when you have the bell. However, at one point you just have the bell, and if you only have the bell and never the food, over time that response is going to wane. Spontaneous recovery is just after a pause, the conditioned response appears just because that is still firmly established in your brain. So, to quiz yourself, the first step of classical conditioning, when a neutral stimulus becomes a conditioned stimulus, is called what? Acquisition. When an unconditioned stimulus no longer follows the conditioned stimulus and the conditioned response becomes weakened, this is called what? Extinction. So let's talk about generalization and discrimination. Generalization is the tendency to respond similarly to stimuli that resemble the conditioned stimulus after conditioning. We have some examples about this in a little bit. Discrimination is the learned ability to distinguish between a conditioned stimulus and other potentially likely connected but irrelevant information. So what conditioning principle is affecting the snail's affections? Generalization. Because the tape dispenser looks a lot like the snail has generalized to the tape dispenser that he has fallen in love. So Pavlov's legacy is that he showed how learning can be studied objectively. You didn't have to get in the minds of someone to understand that learning happens. Many responses to many stimuli can be classically conditioned in many other species. So just to take classical condition example in everyday life, Pavlov's principles do influence human health and well-being. For example, patients can develop a classically conditioned side effect to drugs given as cancer treatments. They may just walk into the room where they know they're going to get the chemotherapy and start to get nauseous even before receiving the chemotherapy. Former drug users often feel a craving when they are again in the drug-using context. So similar situation, they go with their friends to a party and they're like, oh, when I'm at a party, I want drugs. But, if they may be trying to not stop, so if they're former drug users, they probably shouldn't go to the party because they may not trust themselves to stop, to not do the drugs. In the famous experiment by Watson and Raymer, little Albert learned to fear a white rat after repeatedly experiencing a loud noise as the rat was presented. In these experiments, what was the unconditioned stimulus, the unconditioned response, the neutral stimulus, the conditioned stimulus, and the conditioned response? So the unconditioned response, or unconditioned stimulus, was a loud noise. The unconditioned response was the fear to the noise. The neutral stimulus was the rat. Before the loud noise, the baby actually thought the rat was sort of cute and tried to pet it. The conditioned stimulus was the rat after pairing it with the loud sound, and the conditioned response was fear of the rat. Operant conditioning. We'll talk about B.F. Skinner's experiments, Skinner's legacy, and then we'll contrast classical and operant conditioning. Skinner's experiments were built on Thorndike's law of effect, which says rewarded behavior is likely to be repeated. Reinforcement is any event that strengthens the behavior that follows. For instance, in this picture, after being rewarded with food when correctly spotting breast tumors, pigeons became as skilled as humans at detecting cancerous tissue. For his famous cat in a puzzle box experiment, Thorndike used a fish reward to entice cats to find their way out of the puzzle box through a series of maneuvers. So here, going from left to right, we have the number of times the cat was in the puzzle box, and going up from top to bottom is the time required to escape. So the cat's performance tended to improve with each successive time it was in the box. That's illustrating Thorndike's law of effect. An operant chamber, also known as a Skinner box, is a box that contains a bar or a button that an animal can use to obtain a food or water reinforcer. There are attached devices that record the animal's rate of pressing or pecking. You can shape behavior. So this is a procedure in which reinforcers guide actions to get closer and closer to a desired behavior. Researchers and animal trainers gradually shape complex behaviors by rewarding desired behaviors and ignoring other responses. So for instance, if you want a dolphin to take his, I think it's called a snout, to pop a ball up in the air, first you just You give the dolphin a fish for just going near the ball. Then you give the dolphin a fish for touching the ball with its snout. Then you give the dolphin a fish. You get the idea. So eventually you shape the behavior in gradual steps, with the first behavior being something that's naturally done. Well, all of them are something that's naturally done, but it just gets closer and closer to your desired behavior. So some ways to increase behavior in operant conditioning are positive and negative reinforcement. Don't let the terms confuse you, just think about them the way they are. Positive is something you like. So think of, in the description here, positive is you add a desired stimulus. So you're adding something you like. You're reinforcing a behavior with something the person likes. The example is you pet a dog that comes when you call it. You pay the person who paints your house. You give them something that they desire, that they like, for doing the behavior you want them to do. Negative reinforcement involves a negative stimulus, but you're actually removing it here. So for instance, when you take a painkiller to end your pain, you're more likely to repeat that if it worked. You fasten your seatbelt to end the loud beeping in your car. You get the idea. You want something to go away, so you do the behavior that's needed to make it go away. So, just to quiz yourself, how is operant conditioning at work in this cartoon? The toddler says, "This is great. I'll have to wake up crying in the middle of the night more often." Well, the toddler negatively reinforces her parents' behavior, who just want to go back to sleep, when she stops crying once they grant her wish. But interestingly, her parents positively reinforce her cries by letting her sleep with them. It's a difficult thing to do for a parent. You want them to stop crying, but you want to make sure you do it in a healthy way. Types of reinforcers. So there are primary reinforcers, conditioned reinforcers, also called secondary reinforcers, immediate reinforcers, and delayed reinforcers. So all of these are different in that whether they are first associated, well, let me just describe them. So when you see the primary reinforcers, the description is that it's unlearned and innate. They often satisfy a biological need. So when you present food to someone, they may start salivating, or they may just get happy because they see food that they're about to eat. It's unlearned. It happens naturally to anyone. Conditioned reinforcers is they gain reinforcing power through their link with primary reinforcers. So there's something that you learn to associate. Oh, when you walk in a restaurant, you know that food will happen. Normally walking into a building isn't going to do much, but when you walk into a restaurant, you smell the food. You smell the food, you start to salivate because you know you're about to eat. Immediate reinforcers, just like it sounds, is that the rewards are immediate. There's not much time in between when you do the behavior and when the reward happens. Delayed reinforcers, or like it sounds, there's some time in between when the behavior happens and when you want to reward it. So let's talk about reinforcement schedules. It's basically a pattern that defines how often a desired response can be reinforced. Learning occurs rapidly with continuous reinforcement. So every time it happens, every time the desired behavior happens, you reinforce it. That's continuous. But this can cause rapid extinction, because what happens when you stop reinforcing the behavior? So partial or intermittent reinforcement results in slower acquisition, because it takes a little time to catch on. Oh, so when I do this behavior, I get this reinforcement. However, because you learn that you don't always get it, but sometimes you get that reinforcement, there's greater resistance to extinction because you don't know, well, is the reward actually never going to happen again, or will it happen, but just not right away? So let's talk about schedules of partial reinforcement. As you can tell from this table, there are 4 different types, and it's distinguished by the ratio versus interval and fixed versus variable. So for a fixed ratio, it happens every so many times. So the reinforcement after every nth behavior, such as when you buy 10 coffees, you get 1 free, or you pay workers per however many products that the worker produces. A variable ratio it's after an unpredictable number. Reinforcement happens after a random number of behaviors. So this is like when you're playing a slot machine. It doesn't happen every time, but it could happen, so you keep trying. Or fly fishing. You don't always get a fish for every cast, but you get it sometimes. A fixed interval is every so often, reinforcement for behavior after a fixed time, such as a Tuesday discount price. And the variable interval is unpredictably often, so reinforcement for behavior after a random amount of time, as when checking your phone for a message. Sometimes it's there, sometimes you don't have a message. But you still have to check because you just never know if you're missing an important message, right? So just to quiz yourself, people who send spam are reinforced by which schedule? And home bakers checking the oven to see if cookies are done are reinforced on which schedule? So the answer is that spammers are reinforced on a variable ratio schedule. After a varying number of messages, some schmuck falls for whatever they're trying to get them to buy. Then, for home bakers, cookie checkers are reinforced on a fixed interval schedule. They know that every 12 minutes they set the timer and they go in and they check the cookies and they should be done. So whereas reinforcement increases a behavior, punishment does the opposite. Punishment is any consequence that decreases the frequency of the behavior it follows. For instance, when you touch a hot stove, the pain that it causes makes you not want to ever do it again. There are 2 types of punishment. Positive punishment, when you give an aversive stimulus in response to a behavior that you don't want to happen anymore, such as spraying water on a barking dog. And there's negative punishment, such as withdrawing a rewarding stimulus, such as taking away a misbehaving teen's driving privileges. Hopefully that never happened to any of you. So we have to talk about spanking because it's part of punishment. So spanking is a physical punishment. Spanking does reduce the chances of that particular behavior happening again. However, it may reinforce parents' punishing behavior, and it can teach the child to fear the punisher. The child may discriminate among situations and only do the behavior when the punisher is not around. Spanking done in love, not anger, actually does seem to be helpful. The thing is, many experts that say spanking is terrible lump all type of spankings in the same category. And there is a big difference if the spanking is done in love, not anger. I actually have spanked my own children when they were younger. I was raising them solo because their dad was deployed in Iraq, and I was the nurturing, loving mommy, and they didn't really respect my authority that well. So I needed to have something that worked. And so I learned about how to spank in love, and it did work. So how do you do that is the parent takes some time to calm down before administering the spank. You take the child to a private area, usually a restroom or something like that, where the 2 of you are alone, so you don't embarrass the child in front of whoever else is around. You explain to the child that he or she did something wrong and why it was wrong and not okay. You then tell the child the number of spankings he or she will receive and calmly administer them. Then afterwards, you hug the child, telling the child, I love you, now let's figure out what you can do next time instead of whatever behavior it is. This is actually something, like I said, that worked for me, and it's in the Bible. It says, spare the rod, spoil the child. Not like you're supposed to beat the child all the time, but as it says here, you need to punish appropriately and in love, just as God does. He doesn't punish us in anger and nastiness. He punishes us in love so that we can move forward, moving on and growing from the experience. Time to quiz yourself again. Fill in the blanks below with one of the following items: negative reinforcement, positive punishment, negative punishment. The first answer, positive reinforcement, is provided for you. So as we see here, when you take away a desired behavior, it is a negative punishment. When you give an undesired or aversive stimulus, it's a positive punishment. When you take away an undesired or aversive stimulus, it is negative reinforcement. So just take some time and learn through these things, and you'll do fine on the test. So in B.F. Skinner's legacy, on the positive side, he urged people to use operant principles to influence the behavior of others. There have been a lot of excellent things that have been around in as far as parenting advice and things that rules for how teachers should behave and whatnot to their students that have come from this. So lots of good things. However, he has been criticized for neglecting people's personal freedom and advocating that there should be external control over others, that you can shape people's behavior and get them to what you want. So, applications of operant conditioning. At school, many of Skinner's ideals for education have been made possible with the help of digital learning. At work, there are reinforcers that are used to influence productivity. The harder you work, the more units you produce or whatever it is, you get a bonus, for instance. In parenting, desired behavior is increased by giving attention and other reinforcers when the children are behaving well. You can use operant conditioning on yourself to build your strength, setting and announcing realistic goals in measurable terms. By setting them, it gives you a practical action step plan to follow, and announcing them means you have some accountability to others. You decide how, when, and where you'll work toward your goal. And monitoring how often you engaged in the desired behavior. Reinforcing your desired behavior and reducing the rewards gradually. So if you want to learn to do something more, so for instance, you want to exercise more, decide what your plan is, how, when, and where it's going to work, and then how often you're going to monitor it. For instance, I bought a Fitbit so that I could walk more. And it's ridiculous how much I look forward to getting my 10,000 step goal. I never would have really cared that much about if I was exercising that particular amount each day, but now I really get excited when I get my 10,000 steps. And I'll keep you posted on how I'm losing weight or not in my Fitbit. I know you're curious. But anyway, it is reinforcing. It's good to have that reinforcing of it. It does little fireworks on your wrist every time you get 10,000 steps, and also over the long term, lose weight and get healthier. Those are excellent reinforcements for continuing to go. So just to quiz yourself, Ethan constantly misbehaves at preschool, even though his teacher scolds him repeatedly. Why does Ethan's misbehavior continue, and what can his teacher do to stop it? So the answer, if Ethan is seeking attention, the teacher's scolding may be actually reinforcing rather than punishing. To change Ethan's behavior, his teacher could offer reinforcement, such as praise, each time he behaves well. I used to work for a summer day camp treatment program for kids with attention deficit disorder, and the leader of the director of the program always said, "Catch them being good." So when you catch them being good, do something. They'd shout out. They'd actually earn points that we would code. So whenever we'd catch someone being good, we said, "Ooh, 10 points for being helpful," or 10 points for whatever it is. And then at the end of the day, they could cash in their points on prizes that were awesome for kids to have. So just to continue our answer, the teacher might encourage Ethan towards increasingly appropriate behavior through shaping. Sitting down for 5 seconds, and then sitting down for 10 seconds, and then sitting down for, you get the idea. You could also rephrase the rules as rewards instead of punishment, such as, you can have a snack if you play nicely with other children, which is a reward, instead of, if you don't sit down, you are going to lose your recess. So let's compare classical and operant conditioning. The basic idea for classical conditioning is that there are learned association between events we don't control. So the presentation of food paired with the bell produces salivation. The dog didn't control the bell or the food, it just salivated in response to the food. In operant conditioning, we learn associations between our own behavior and its consequences. So we choose to do a behavior and we get the resulting consequences. The response in classical conditioning is involuntary and automatic. The dog slobbered no matter what, just because the food was presented to them. In operant conditioning, the response is voluntary, because we're the operators choosing to do it. Classical conditioning, acquisition happens with associating events. Specifically, the neutral stimulus is paired with an unconditioned stimulus and becomes the conditioned stimulus. In operant conditioning, you associate the response with the consequences, either the reinforcement or punishment, whichever it is. Classical conditioning, as the conditioned response decreases when the conditioned stimulus is repeatedly presented alone. So the bell by itself eventually may not get the slobber response, depending on how well it's established or how often the food is presented with the bell. In operant conditioning, extinction happens. Your response decreases when reinforcement stops. In classical conditioning, there's something called spontaneous recovery, which is the reappearance after a resting period of an extinguished conditioned response. In operant conditioning, this reappearance also happens after a rest period of an extinguished response. In classical conditioning, generalization is responding to stimuli that appear similar to the conditioned stimulus. In operant conditioning, it's responding to similar stimuli to achieve or prevent a consequence. It's something that you've learned. If you learned that walking into a classroom is going to be a positive experience, then you learn, walking into any classroom will always be a positive experience. Classical conditioning, discrimination, learning to distinguish between a conditioned stimulus and other stimuli that do not signal an unconditioned stimulus or response. In operant conditioning, is learning that some responses, but not others, will be reinforced. So if I walk into any building, it won't always be a positive experience. It's just walking into classrooms that will be positive. So just to summarize it a little more simply, classical conditioning involved learned association between events that are not controlled by the learner, and it involves respondent's behavior. In operant conditioning, the learner associates his or her own actions with the consequences. It involves an operant behavior. So, just to quiz yourself, with classical conditioning, we learn associations between events we do or do not control. Do not. And with operant conditioning, we learn associations between our behavior and resulting or random events. Resulting. Salivating in response to a tone paired with food is a blank behavior, and pressing a bar to obtain food is a blank behavior. Salivating in response to a tone paired with food is a respondent behavior, and pressing a bar to obtain food is an operant behavior. Now let's talk about the biology and cognition involved with learning. First, there are biological limits on conditioning, and there are cognitive influences on conditioning. There are some biological limits on conditioning. Natural selection favors traits that aid survival. So things that would naturally help us to be a better hunter, a better person, a better whatever, we're more likely to learn something that is related to that, to being a better hunter, being a better person, etc. There are biological constraints, evolved biological tendencies that predispose animals' behavior and learning, kind of just like I said. There are limits in classical conditioning in that humans are biologically prepared to learn some things rather than others. Like I mentioned, if there are things that will help you to survive or to become stronger or whatnot, this will be a behavior that is more likely to learn than something that doesn't. You can still learn them, it's just that they're a lot easier to learn, and it's a lot easier for the average person to learn. There's something called latent learning, and Skinner learned that animals, like people, can learn from experience with or without reinforcement. So if you put a rat in a maze, he'll eventually learn to get out, and what the map is, we'll talk about in a second, on how to get out. So let's talk about cognition and operant conditioning. Rats that explored the maze without a food reward developed a cognitive map. This is just a mental image of the layout of the environment of the maze. They demonstrated latent learning once a food reward was given at the end. So once they knew that there was the possibility of getting food at the end of the maze, they were likely to just zip through that maze that they had already learned with greater speed. The thing is that excessive rewards can destroy intrinsic motivation, and that is the desire to perform a behavior just for its own sake. So wanting to do something just to say you could do it instead of wanting to do something so you know that you get a reward. People who focus on their work's meaning and significance do better work. And it doesn't hurt to get a paycheck, the external reward of a paycheck. So let's quiz ourselves. Latent learning is an example of what important idea? The success of operant conditioning is affected not just by environmental cues, but also by cognitive factors. So that's obvious in that the rat knew how to get out of the maze, or learned how to get out of the maze when there wasn't any kind of pellet to reinforce them. So they had the cognitive function going on to process their cognitive map and then when it became apparent that there would be some kind of environmental cue, they learned it faster. So let's talk about learning by observation. We'll talk about mirrors and imitation in the brain, applications of observational learning, and then we'll think critically about the effects of viewing media violence. Albert Bandura is a famous psychologist that has to do with observational learning. And just like it sounds, it's learning by observing others. It involves modeling, observing and imitating a specific behavior. There is something called vicarious reinforcement or punishment. And the word vicarious means sort of you learn by someone else. It helps you help to anticipate the behavior's consequences simply by watching what happens when someone else does it. Dr. Bandura conducted a famous Bobo doll experiment. So picture this scene from the experiment. A preschool child works on a drawing. In another part of the room, an adult builds with Tinker Toys. As the child watches, the adult gets up and for nearly 10 minutes pounds, kicks, and throws around the room a large inflated Bobo doll, yelling, "Suck him in the nose, hit him down, kick him." The child is then taken to another room filled with appealing toys. The experimenter returns and tells the child he has decided to save these good toys for the other children. She takes the now frustrated child to a third room containing a few toys, including a Bobo doll, left alone. What does the child do? So compared with other children in the study, those who viewed the model's actions were more likely to lash out at the doll. Apparently, observing the aggressive outburst lowered their inhibitions. Let me just give you a little bit about what I'll call Neuron 101. Neurons are the cells in a brain. Chapter 2 covers this more in detail, and since we skipped ahead, I wanted to make sure I gave you just a little bit of an understanding. Neurons are little cells that carry information from one part of the brain to the other. There's a space in between called a synapse that permits a neuron or nerve cell to pass an electrical chemical signal to another neuron. This is referred to as firing. There's actually like an electrical current that's passing through. That's where the firing comes from. The activity in the brain involves intense social activity because we're social people. A mirror neuron is something that fires when you perform a certain action and when you observe someone else performing that same action. This is the neural basis for imitation in observational learning, the mirror neuron. So let's talk about experienced and imagined pain in the brain. So these pictures depict a functional MRI activity when someone is experiencing pain or listening to a loved one experiencing pain. Brain activity related to actual pain is mirrored in the brain activity of someone who is observing pain, not as high or not as much, like the picture of the functional MRI on the left is when you experience actual pain. The one on the right is when you are watching someone else in pain. So empathy in the brain shows up in areas that process emotions, but not in the areas that register actual pain. So applications of observational learning. For pro-social effects, which pro-social behavior is just positive, constructive, and helpful behavior, is the opposite of antisocial behavior. So pro-social behavior models have pro-social effects. When you watch someone pick up trash down the street, you're more likely to pick up trash down the street and throw it away. Its effectiveness is related to consistency in actions and words. You may tell your child to pick up after themselves, but if you don't pick up after yourself, then they're not learning that it's a good thing to pick up after yourself. There are antisocial effects. Observational learning may have adverse effects. There are TV shows, movies, and online videos that are sources of observational learning. If we learn that being disrespectful is cool, that it's okay to kill someone, or whatever, these antisocial behaviors are being reinforced just through observation. And we also learned that aggressiveness could be genetic in nature, that there are certain people who are more predisposed to be susceptible to be aggressive, and so when it's modeled to them, they are more likely than someone else who observes aggressive behavior to be aggressive. So what we have here, children who are watching violent things, there's a 7-fold increase in violent play. If you have limited exposure to violent programs, there's reduced aggressive behavior. It's just plain out there. They don't have the ideas in their brain. They're not primed and ready to happen, so they just don't. Also to do with violence, if you just are exposed to prolonged levels of violence, game after game after game after game, where it's okay to kill someone, later when viewers are watching something, it's not a big deal when they see that there's killing or violence. So you become desensitized to it. Adult males spent 3 evenings watching sexually violent movies, and then viewers became progressively less bothered by the violence that was shown. Compared to a control group, they experienced less sympathy for domestic violence victims and rated their victims' injuries as less severe. So if you were a violent moviegoer, you were less likely to help than a non-violent moviegoer in this situation. So the APA Task Force on Violent Media found that research demonstrates a consistent relationship between violent video game use and increasing aggressive behavior, aggressive cognitions, and aggressive affect. It decreases prosocial behavior, empathy, and sensitivity to aggression. The American Academy of Pediatrics has advised pediatricians that media violence can contribute to aggressive behavior, desensitization to violence, nightmares, and fear of being harmed. So, let's think critically. There are some effects of viewing media violence. It actually does increase homicidal rates. When you look at when TV violence started and homicidal rates, that's killing people, they are increased. There's also been an increase in violent behavior among teens since the introduction of more media violence. There have been experimental studies that have found violence viewing participants react more cruelly when they're provoked. And this is prompted by imitation of what you observe and desensitization, just getting so it doesn't impact you anymore. You don't think it's a big